Okay, so this right here that we've been doing, atomic structure, is a very big unit. We've been working on it for 2 weeks now, and it's actually going to continue up until right before Thanksgiving. So, big unit. We had a vocabulary test yesterday, and tomorrow we are going to have another test. Now, this test that we're going to have tomorrow is going to be, it's going to be on Thursday. It is going to be an assessment for me to see how well you know the information that we've been going over. So the first thing that we're going to go over is the historical contribution to the atomic theory. Now, the first guy we talked about was Dalton, John Dalton. He's the one that proposed the atomic theory. So he was a very important guy. Then we have Thomson. He is going to be the guy who discovered the electron. He had what we called the chocolate chip model, or the plum pudding model, where the cookie itself was positive, but then the little chocolate chips inside were negative. And the way that he did this was with his experiment with the cathode ray tube. Then we had one that's not as well known, is Millikan. Millikan did the oil drop experiment. And this helped them determine the mass of an electron. Okay, after Millikan, we had good old Rutherford. And Rutherford is known for discovering the nucleus. And he did this with his experiment that had the gold foil in it. Gold foil experiment. Then there's one that we did not put on to the timeline, but I want to bring up. Chadwick. Chadwick discovered the nucleus. Discovered the neutron. I said nucleus, I meant neutron. Discovered the neutron. And then we had Bohr. He came up with that model that we learned about yesterday. And remember that Bohr said that the electrons are outside the nucleus and exist in certain levels. And then last but not least, we had Schrodinger. He came up with the quantum theory, the fancy pants theory. And this says that our electrons are in orbit. Okay, now, once we get past the historical contribution, what we've been talking about is the atom in general. We have our protons, neutrons, and electrons. You have your nucleus. And remember, if you were to draw this, okay, this guy right here would be your nucleus. This would be a plus, it would be a proton. This would be a no charge, it would be a neutron. And then around this, you would have these little negative things called electrons. Now, the other thing is, what do the squares on the periodic table mean? Okay, so we have 1H, 1.00, something like that. Okay, this right here is your atomic number. And this gives you your P's and E's, your protons and electrons. Now, the electrons is for a neutral atom. If we had an ion, it's going to be different. This right here is the atomic mass number. Okay. Now, the other thing you have to be able to do is ape man. Okay, so ape man is the atomic number that equals your protons, that equals your electrons. We just went over that. And then you have man. This is your mass number, so this guy, minus your atomic number. Subtract them, and you get your neutrons. Another way to think about your neutrons is that you're going to subtract the two numbers in the periodic table. Subtract two numbers in periodic table. One other thing that you need to be able to calculate is the mass number. And to get the mass number, it's going to be your protons plus your neutrons. Okay, protons plus your neutrons. Okay, so we did that. The next thing we did were we talked about ions and how they had charges. We said there were two types, cations. Remember the T makes a plus, so these are positive. And then we have anions, which are negative. To become a positive, you have to get rid of the negative. So that means we're going to lose electrons. And then anions, to become negative, you have to gain electrons. Now, on practice the other day, y'all had to fill in a chart, and it would give you something, and you would have to tell me if it gained or lost electrons and what charge it would have. So if I told you that we had aluminum plus 3, well, that means that the number's 3. We did something with the 3. But look, we're positive. So did we get rid of or did we gain electrons? To become positive, you got to get rid of the negative. So we actually lost 3 electrons. E minus is my symbol for electrons. So we lost 3, and that made it positive. Okay. Now if I had chlorine minus 1, well, the number's 1, so 1 electron did something. Now this guy said it's negative. To become negative, you have to take it in. To become negative, you got to take in the negativity. So you're going to gain 1 electron. And then the last thing we went over were isotopes. Remember with the isotopes we have something like this. That means carbon 14. And 14 is your mass number. And then we have isotope notation. We have X, which is your element, and we have A to Z. A is going to be your mass number, and Z is going to be your atomic number. Now remember with isotopes, it has a different number of neutrons and a different mass number. Okay, so you need to know what isotopes are. We've done practice on all of these, and I tried to do chunks, so hopefully it stayed in your mind and it's not too difficult yet for you. All right, hope this makes sense. If you have any questions, please email me and let me know.